So hello students, in this video we are going to talk about a very special topic of ionic equilibrium, that is dissolving a precipitate by complex formation. It is a part of solubility equilibria in which we are going to talk about the role of complex formation on solubility of a salt. A sparingly soluble salt, when precipitated, can be redissolved in some cases by adding some reagent which form complex with the precipitate, which is commonly used in qualitative inorganic analysis. Like we must have heard about a confirmatory test of silver ion. In laboratory, silver ion is in the first group of qualitative analysis. So silver ion is first precipitated by adding dilute solution of HCl where a white precipitate is formed, and the precipitate dissolves in excess of ammonia. That is confirmation of silver ion. So ammonia is the complexing agent, and when ammonia is added to the solution containing silver chloride precipitate at the bottom, ammonia reacts with precipitate and redissolve it, bring back into solution by forming a complex. So how complex formation is going to affect the solubility of a sparingly soluble salt and how it is calculated quantitatively is going to be the point of discussion in this video. So let us suppose we want to dissolve silver chloride precipitate in ammonia. Ammonia dissolves silver chloride by forming complex AgNH3 whole twice plus and chloride ion. So this is one complexation reaction involving a sparingly soluble salt silver chloride, which is being dissolved here by a complexing agent ammonia by complex formation. Now if you want to know how much of AgCl will dissolve in a given solution of ammonia, we will have to solve this equilibrium reaction. We will have to solve this equilibrium. For that reason, for that purpose, we'll have to derive the expression for Kc. So Kc for this reaction will be equal to concentration of the complex ion AgNH3 whole twice plus into concentration of chloride ion divided by concentration of ammonia power 2. So now this is the expression for Kc which will have to be solved in order to solve the problems, in order to determine the solubility of silver chloride in ammonia solution. Now this Kc will not be given directly. So it will have to be derived in terms of another constant, standard constant given in the question. So suppose if we multiply it by chloride ion concentration and multiply it by silver ion concentration. If we multiply it by silver ion concentration and divide it by silver ion concentration, what is going to happen? Here, this product is nothing but KSP of silver chloride. So, one term in the numerator is KSP of silver chloride. What is another term? It is AgNH3 whole twice plus concentration divided by concentration of silver ion into concentration of ammonia raised to the power 2. The quantity in the bracket is called formation constant Kf of the complex. Kf, let us define once. Kf, which is read as formation constant of complex. It is Kc for the formation of complex from the metal ion and ligands. So in diamine silver complex, the metal ion is silver ion and the ligand is ammonia. So the formation from the constituent of complex can be written like this, and Kc of this is simply Kf, which is concentration of AgNH3 whole twice plus divided by concentration of silver ion into concentration of ammonia raised to the power 2. So now we can see this is same as the quantity in the bracket in the above expression. So this is nothing but Kf. So now we can say that Kc is Kc, which Kc? This Kc is nothing but Ksp into Kf. But an important point here I want to make it that this expression for Kc must be derived every time. It should not be taken granted that it is always Ksp into Kf. It could be different depending upon the salt and the complex formed from the salt. So it must be derived for every salt. Now Ksp and Kf are given. If Ksp and Kf are given, Kc can be known. Once Kc is known, this expression can be solved like simple chemical equilibrium. So let us try a problem. Given that Ksp of silver chloride is 2 into 10 raised to the power minus 10 and Kf of AgNH3 whole twice plus complex is 10 raised to the power 8. Determine molar solubility. Determine molar solubility of AgCl salt in 0.2 molar ammonia solution. This is a straightforward problem based on the expression we derived just now. So we can say that the solid AgCl will dissolve in ammonia by forming the complex AgNH3 whole twice plus. So the complex formation reaction is AgCl plus 2NH3 gives AgNH3 whole twice plus Cl minus. So the Kc here we have just derived will be Ksp into Kf, whose value will be 2 into 10 raised to the power minus 10 into 10 raised to the power plus 8. So it is 2 into 10 raised to the power minus 2. So this Kc is now derived. Once Kc is derived, now we can solve this. Let x mole per liter of AgCl is dissolved. X mole per liter of AgCl is dissolved. Initial concentration of ammonia is 0.2 molar. So if x mole of AgCl is dissolved, 2x mole of ammonia will be reacted. So here it will be minus 2x, here it will be x and x. So the expression for Kc will be concentration of AgNH3 whole twice plus into concentration of chloride ion divided by concentration of ammonia raised to the power 2, which is now x, both are x, so x square. So x into x divided by 0.2 minus 2x square, which can be written as x upon 0.2 minus 2x whole square, which is equal to 2 into 10 raised to the power minus 2. Kc we have already derived. So taking square root on both sides, we can find out x upon 0.2 minus 2x. So better we take 2 common from the denominator. So 2 into 1 minus 0.1 minus x, 0.1 minus x will be equal to square root of 2 into 10 raised to the power minus 2. So it will be root 2 into 0.1. So root 2 into 0.1. Root 2 is 1.4. So into 0.1 will be 0.14. So x upon 0.1 minus x will be 2 on the other side, will make it 0.28. So x will be equal to 0.028 minus 0.28x. So x will be equal to 0.028 divided by 1.28. If we solve this, it comes out to be 0.028 0.0218. 0.0218, approximately 0.022 molar. That is going to be the answer. So that is how complex formation affect the solubility. Complex formation increases solubility. So by forming diamine silver complex, silver chloride is dissolved here. Let us work out one more problem to illustrate it further. Given solubility product of Ag2CrO4 silver chromate is 2 into 10 raised to the power minus 12, and Kf of AgNH3 whole twice plus is 10 raised to the power 8. Determine molar solubility. Determine molar solubility. Determine molar solubility of silver chromate in 0.04 molar ammonia solution. Now it is again a similar type of question. So first let us write the solubility equilibrium dissolving reaction. So dissolving reaction by complex formation can be written as Ag2CrO4 plus ammonia giving the same complex AgNH3 whole twice plus CrO4 2 minus. So here we have 2 silver on the left, so this must be 2. So 2 into 2, 4 ammonia. Now it is a balanced reaction for which the Kc will be equal to concentration of AgNH3 whole twice plus square into concentration of chromate ion divided by concentration of ammonia raised to the power 4. Now let us multiply it by square of the concentration of silver ion and divide by the same. Now it is concentration of silver ion whole square into concentration of chromate into concentration of AgNH3. Better we write it in a separate line. So it is equal to concentration of silver ion square into concentration of chromate ion, silver ion square, chromate ion, into concentration of complex ion AgNH3 whole twice plus divided by concentration of silver ion into concentration of ammonia square and this whole square. So within the parenthesis it is nothing but Kf. So this expression is this is KSP and this is KF. So the whole term is KSP into KF square. So I reminded in the beginning that this Kc should not be taken granted as KSP into KF. It will have to be derived independently for each salt. And now for this salt, it is derived as KSP into KF square. So now the value of Kc, which is KSP into KF square, is 2 into 10 raised to the power minus 12 into 10 raised to the power 8 square. So 8 square is 16. So it is 2 into 10 raised to the power 4, which is a very large value. This Kc is now very large value. So now we can say that this dissolving equilibrium will lie predominantly to product side. So we can say that the entire ammonia will be consumed in this dissolving reaction. Let us write once more that reaction: Ag2CrO4 solid plus 4 ammonia aqueous giving 2 AgNH3 whole 2 plus CrO4 2 minus. Initial concentration of ammonia is 0.4 molar given. Yeah, 0.04 molar. 0.04 molar. Now the question is, what is the molar solubility of silver chromate in 0.04 molar solution? And for this reaction we have derived Kc 2 into 10 raised to the power 4, which is a very large value. So we can say that ammonia will be consumed completely, as this reaction will go predominantly to right, and 1 mole of silver chromate is reacting with 4 mole of ammonia. So actually 0.01 mole of this will react with 0.04. So it will be consumed completely, and 1 mole of this produces 2 moles, so 0.01 will produce 0.02 and 0.01 mole of chromate. The equilibrium will lie predominantly to right, so 0.01 mole of this will dissolve. So molar solubility can be directly taken to 0.01. There is no need to take fourth root at all. So solubility is 0.01 molar approximately.